All right. Hey guys, welcome. We're going to be talking about kinetics. Okay. Um, so one question that I was going to ask, but I kind of forgot to ask about it, but it's basically because this is just kind of going back from module two, but if you guys recall from like Van Hoff factors and stuff and like delta T, right? The change in like when colligative properties are there, you decrease the freezing point and increase boiling point, right? Because there's like a delta T. It's gonna ask like, why do we still see ice forming even though there's already salt on the ground? Why? What are some factors for that? You guys can recall that.
Salt depresses freezing point,
Mhm.
but it's getting colder as well.
Yeah.
So doesn't really do much.
Yeah, so like one thing is that the temperature has been below 0 degrees Celsius, right? And so even though that there is a lot of salt, it might not be enough salt because the delta T would be not enough, right? So there's still freezing that's happening even with the salt present. So that's why it's important to put sufficient amounts of salt for that, right? I don't know if you guys remember the formula from last module, but it's delta T equals IKF and then M. M stands for molality, right? And this is something you probably could see on the MCAT. I think I saw something with osmotic pressure, right? Osmotic pressure was, oh gosh, P or I think it's like pi equal, right? So this is the osmotic pressure thing. I don't really remember like the specific symbol for this, but that's the whole idea with that. I had a question like that where it talked about like NaCl, so the Van Hoff factor would be 2. And then you got molarity, you got gas constant, which is 0.08206 atm liter over mole times Kelvin, and then temperature is in Kelvin, right? Okay, so that's just a little bit of review and thinking about that in a real life scenario. Now we'll talk about some kinetics. We're not going to get into integrated rate law because you guys didn't go over it yet. You guys will go over it on Tuesday, probably, and then Thursday you guys will do the like intermediate slow rate determining steps. You know what I mean? Yeah. Okay, but you guys will learn even if you don't know it.
When I take the MCAT next year, are there gonna be integrated rate law?
There could be a question regarding integrated rate law. It wouldn't be a difficult question where you won't be able to like do the math for it. Or they might just ask you to like plug in plug in the variables that you need in the expression. So like you might need to be able to identify if it's zero order or first order or second order. But yeah, like you won't need to do the math for it. Which makes sense. The harder thing isn't doing the math, it's identifying what you need to do, right? Which is exactly what the MCAT asks. And also what Professor Yusuf asked. So yeah, this is all a bunch of yap. Yeah, the change in products and reactants, right? So for every 2 moles of nitrogen dioxide, you form 2 moles of nitrogen monoxide, right? So the rate of disappearance of nitrogen dioxide is equal to the rate of appearance of nitrogen monoxide. But then likewise, the rate of disappearance of nitrogen dioxide, right? So that for every 2 NO2s, 1 oxygen gas molecule is produced. So in some ways, you could say that the rate of disappearance of nitrogen dioxide is double the rate of appearance of oxygen, if that makes sense. Okay. Or likewise, you could say that the rate of appearance of oxygen is 1/2 the rate of disappearance. It's a bunch of semantics, but they could ask a question like that. Yeah, so they're just showing how like it all kind of levels out in kinetics like that. Yeah, the rate of reaction or reactant consumption is not always constant. That makes sense because in the beginning it's just going to be super like reactive, but then over time we'll talk about an equilibrium, right? Things kind of level out. And so yeah, this is just a bunch of yap. We did this in class already, if you recall, but we can look at it again. Is there any questions about this? You guys want me to go over it? Okay, this is something that they could actually ask on the MCAT for sure, because it's not so bad to do this math. This is pretty easy math to do, even if it looks like it's bad. But yeah, you just use the mole ratios. That's essentially what you do with that. Yeah, if you guys have questions about that, let me know and I'll go over it. Yeah, this was a question I asked last year, but yeah, if you guys want to spend some time answering it, you guys can. So I'll give you guys a minute or two to do it. Figure this out. But yeah, also. Guys can- Very good. But it's okay. All right. What's the answer, you guys? Which one?
D.
D, the rate of appearance of hydrogen gas is 1.5 times the rate of the disappearance of ammonia gas. Yeah, I think it's right. Let's see. It's right. Woo! Good job. Good job, Da Vinci. All right. Anyways, okay. So anyways, so these are just some factors that can increase the rate of like the reaction rate, right? So temperature, right? That can affect it. Concentration. If you have an increased concentration of reactants, right? It could cause the rate of the forward reaction to increase, right? The physical states, right? We see that surface area, when you increase surface area, you increase the reaction rate. And the presence of catalysts, right? That we will learn later in this lecture how that works out. But these are really good concepts to know because this is a really easy question to ask on the MCAT as well, right? Like, yeah, like they might say like, oh, if you increase temperature, what do you expect to happen, right? Gotta say that reaction rate probably increases, right? Or if you see concentration decrease, you'll see reaction rate might decrease, right? So these are like, if you know it, you know it. If you don't, you might be a little cooked, right? So it's good to know. And it's good for us use of exams as well because it's the same sort of idea and logic with that. Okay, so this is a little simple question. I'll give you guys 30 seconds to answer it. All right, what are the answers?
A.
You serious? All right, does there anyone else have an answer?
B.
Yeah, it's B. See, increasing surface area. Think of like a cell. If you guys remember cells, right? Like
Yeah.
cells, right? They have all these different like folds in the cell membrane, right? The reason being is it increases the surface area of the cell, right? The cell is not just some circular flat thing, right? There's a lot of indents and all that. Even in the mitochondria, right? There's a lot of indents, right? The cristae and whatnot. There's a reason for that. It's to increase the surface area. And that surface area to volume ratio is why like there's a lot of like like a lot of osmosis and all those sort of things. But it's really interesting. But that's also why like cells evolved to have a high surface area to volume ratio. And that's also why surface area is really important. But yeah. All right. So now we're gonna get into rate laws. I drew here what a rate law looks like, right? If you guys can remember, our from Tuesday that or Thursday that this is what a rate law looks like. So you have the rate, the reaction rate equaling some rate constant named K with some variable concentrations with a level of order which is those exponents there. So that's just kind of the basic idea of rate laws. And so, yeah, like basically you're gonna look at these reactions and you're gonna have to figure out the rate law. Obviously, you can't just get a rate law from just the normal reaction. That's a very important thing. You can't get a rate law from the overall reaction. You can get a rate law from doing the experiment or an experiment. So yeah, this should say it must be determined experimentally, right? That we will learn a different way of finding rate law through the rate determining step, which is what's it called? Like the slow step, which we'll talk about next class or the class after. But yeah, we basically have to use what's it called? This experimental data to solve for that. So I'm just gonna erase this quickly. And let's try to do this. I know we did this in class, but I think it's important to try and redo it, right? So we see here, we got this experimental data. We see that the reaction above is the reaction above, and we have to figure this out. Now I'm gonna challenge you guys. Let's try to do this without using any math, or let's using some mental math, right? Yeah, like if you guys remember, the first step is to identify the, like, what's it called? The experiment or trial that one concentration or reactant changes and the other one remains constant. So a good example could be trial 1 and 2, right? These two trials, right? We see that nitrogen monoxide remains constant, but the O3 remain like doubles, right? We see that it doubles. Okay. And likewise, we see here, it may not look apparent, but it's also doubled, right? 6.6, like if you add that up, that's gonna be around 1.32, right? And you see that the exponents, right? By being familiar with exponents, we see that this is just double this, if that makes sense, right? So what we can do here, but if without doing any math really, is we could do something like we could say that 2 equals 2 to the power of some value. All right. And the reason being is because we see that as this doubles, this also doubles. Okay. It's the same thing as what we did in class where we divided all these things out like this. We divided it out and we put it in the calculator and we did all this nonsense, right? It's so much work. But if you just recognize that this is doubling, right? If this doubles, you can make a simple expression like that. And you can figure out the rate order, in this case would be n equals 1. All right. And so the rate order for ozone, right, is going to be 1 for the first one, right? Now we need to figure out nitrogen monoxide. So I want to give you guys a chance to try to do this. So what experiment could nitrogen monoxide be used for in this case? Yeah.
3 and 4.
3 and 4, perfect, right? So we see here that ozone is remaining constant, right? So it's not affecting anything. But we see that nitrogen monoxide is doubling, right? And we see here as nitrogen monoxide doubles by 2, we see that the rate of the reaction doubles by 2, right? So that's a really important thing. So we can do the same kind of thing here where it's like that. And then we can just say, okay, now we know that this is also a first order sort of thing. So now we know that the rate order of the overall reaction is 2, if that makes sense. So rate equals K. And yeah, the overall reaction order is 2 in this case, and that's pretty good. One other thing that we talked about in class is determining the units for K. All right. And what we can do here, there's a couple things we can do. When determining the units for K, we can look at the rate units, right? So we see that the rate is moles over liters times seconds, right? And we know that on the like rate order, like the K concentration side, that there is two concentrations, right? So there's moles over liter and moles over liter, right? And then there's a K value. We can figure out the units by just canceling out all the units, right? So we see here that if we divide out this concentration by the if we divide the concentration out, we'll see that it's going to be mole over liter, and the same thing over here, it'll be mole over liter, and this cancels out, and you're left with, the unit for K would be liters over mole times seconds. All right, that makes sense? Yeah? Devinder, you good? Yeah, I know. This is a little bit semantical, but this is a very easy MCAT question as well. I think I had a question like this on my exam, where they asked me what the units for K was. And it's not that hard, but if you have a good strategy for figuring this out, this could be less than a minute on the exam. Okay? But yeah, does anyone have any questions about this? Okay, all right. Let's see, I gave you guys, let's try to do this practice problem. Okay, so spend some time. I'll give you guys a minute or so to do it. Try to do it without your calculator. All right. Do you guys figure it out yet? You guys want me to go over it quickly? How I do it? Yeah. Okay. So what I would do is I'd see here that we see that the initial we see that the concentration of A as it doubles, right? This is constant in experiment 1 and 2. And we see that as it doubles, the reaction rate doubles, right? So that's simply 2 equals 2n, right? And n equals 1 for A. So anything that isn't that is wrong. So D is wrong, and everything else looks like it's right. E is just, you never see E. Like, that's the truth. All right? Don't fall asleep. Okay? But anyways, next up is we got to look at experiment 2 and 3, and we see that as this times by 5, we see that this is times by a certain number. Yeah. And so even if we're not able to find that number, we can still figure it out. All right. And one thing we can do is we could try to divide it if that feels like we're able to do that. Yeah, so 1 times 10 to the negative 2 over 5 times 10 to the negative 4. We can move things around to make this a little bit better. We could move these like decimal place to, we could do 125 times 10 to the negative 4. That's one way we could do that. So what is 125 divided by 5? 25, right? 25. So 25 n equals 25, if that makes sense. Right? Does that make sense for you guys? So yeah, you basically divide out that reaction rate, and then we see that this has an order of 2, right? 5 squared equals 25. right? So even if we didn't have a calculator, you can figure this out. Okay, that's the whole idea. If you don't have a calculator, on the MCAT, you won't have a calculator. You can figure this out. Okay? So that means B is 2. So, or the answer would be B in this case. Does that make sense? Okay, any questions? You guys chilling?
Could you explain again how you got 5 n equals 25?
Yeah, so when we're doing the rate order, right, we're trying to find the rate order of the concentrate, like the reactant given, right? So we see that A is like there's a different concentrations, right? And so with this, when we see that for A it doubles, right? That's gonna be 2, right? But then we see in 2 to the power some number, right? And then when we see here, it doubles, right? So this is gonna definitely equal 2. So what exponent needs to make that equal to 2? 1, right? So that's A. For B, we see that it like increases by a factor of 5, right? So as the concentration increases, it's gonna be 5, right? And over here, we see that we might not know off the top of our head what's happening there, but we can do math here. And so we see here, I just kind of move the decimal places around. So now instead of it being 1.25 times 10 to the negative 2, it's 125 times 10 to the negative 4, right? Because it's easier to do things with the same exponent value, right? So then after you do that, you see that this is going to be a value of 25 because that's how it is. So it'd be 5n to the 25. And then using exponent rules, you know that 5 squared equals 25. So that's why B is the right answer. All right. Let's see. Let's keep doing this. Okay. Let's try this question. Yes. Now this one you may use your calculator. But I challenge you not to. Try not to use the calculator if you guys feel inclined to do so. Of course, use it if you're not comfortable, but as you know, for the best uses exam, you will be able to use the calculator. And when I say don't use a calculator, that doesn't mean you can't write out things on your phone or write things on your thing. Yeah.
Say E.
For what?
14.
I don't know. But yeah, you guys will have scrap paper or something to do math on, so. Yeah. Use that accordingly.
The units for rate law.
Rate law?
It's like for like one, I guess. Measurements.
What do you mean rate law? Like rate?
Awesome.
How are you asking?
Or like so like A would it be like moles
Moles
per
per liters, concentrate.
and then K is moles, I guess.
It depends. K is always dependent on everything else. Moles is always moles over liters times seconds. Or rate is always moles over liters times seconds. No, so it's dependent on the question, right? So we have different concentrations with different rate orders, right? And then we have the rate, obviously. So if it's, yeah, if it's a second order or third order, it might, like anything that's second order will have the same value for K. Anything that's third order will have the same value for K. But second orders and third orders are not going to have the same value units for K. If that makes sense. Like you could memorize the K values for each. Why's your hair like that? Okay. You could like memorize the units, but it's better to just know how to do it. Cause I think it's a waste of brain space, in my opinion. All right. So let's try to do this without using a calculator, right? So we see here that it's rate, so we're given this concentration, right? So I'm gonna say that this is 4.8 times 10 to the negative 2. Does that make sense? All right. Is equal to K and then 4 squared, and then B is 1. So B doesn't really matter. Okay, so we'll see that this is 16. Okay. And then let's make this 1.6 times 10 to the 1. Okay, making it a little easier to understand. And so then, yeah, you just divide it and you get 3 times 10 to the negative 3. So that's use the right answer. Okay, does that make sense? You guys should be familiar with using the exponents, all right? That's the whole idea. See, this question, it looks complicated, but this could literally be an MCAT question. Very simple, because if you know how to do it, it's very easy. But then if you don't, it's like, oh my gosh, this is so low yield, but it's not low yield, it's pretty simple, right? And then likewise, find the label K, it's pretty self-explanatory as well with that, where you have mole over liter. This is what I literally do, find units, right? There's 3 concentrations there, that's why it's 2 and then 1. So I'll just do this, this, and then this, right? And then I cancel out 1, and then it's gonna be liters squared over mole squared times second. Does that make sense for people? Because there's 2 and then 1. It's a third order reaction, you see? So there's 3 concentrations, yeah.
Over liters times second. Okay.
Yeah. No, this came from the rate reaction rate. Yeah, the reaction rate from the reaction rate given. So this is the reaction rate. And so if you multiply all these things out like that, it looks confusing, but it's actually not. It's pretty fast, right? And then we see that answer would be C. Okay? Yeah. Okay. This is a better way of showing that, but it is what GG's. All right. I should erase this. I want you guys to figure this out, but I didn't. I did it. This is from last year. I didn't. I know he's. I can't show it. I can't show it that. And also, guys, don't mind the question number. It was made last year. All right, let's move. Let's look back in. Yeah, got it. There's no rule, not laughing. I was
Is that a?
no, I was reading a Cars passage on that cat, and it was like this guy that was like criticizing like fast food and like how fattening it is, and like the words he was using was so funny. Like he was like, "How dare like these companies use like ocean-sized cups?" Like he was like, they're like, it was so funny. I like chuckled in the cubicle, and I was like, "What the hell am I reading?" Fine. And then after that, I think we're pretty much it for that. Yeah. Okay.
It actually gets granted, right? They do that. No bad.
They give you a notepad.
That mark.
That's what I mean by
So like, it's like annoying to you.
whatever. I didn't even work for me.
Could you just use better?
You can't bring paper. That's not bad. Fine. Gets the job done. You only need it for 10 quizzes, really. After that, you don't need that. Let's do this. All right. So, what is the rate law? Does anyone have any guesses? E? Okay, all right. We'll see. All right. So, with the rate law, right, we see that W doubles, right? W. Okay. All right. And then we see that the rate of production of Z, right, is 0, right? And so this is one way you can measure the rate of a reaction. You can measure the rate of reaction by looking at the products or reactants. We see that with biochem. You guys will do that later next year with biochem by measuring the rate of carbon dioxide or something, or the rate of some product at the end of an enzymatic reaction, right? If you measure if you measure the like wavelength of that product or whatnot, you can like figure out, oh, what's the reaction rate and the kinetics and stuff. You guys will see that next year in biochemistry, right? But that's beside the point. So this is a way to measure the rate, right? And so yeah, we see that W doubles and the rate of product is like doesn't change, right? So it'd be 2n equals 0. And so what does n have to be? N has to be 0. So that means anything with W is not an answer choice. So we just got 3 answers gone, right? Now let's look at X, right? Because why we look at Y when Y is gonna have to be double, right? So let's see X. So we need to find one where X is the one that changes and Y and W remain the same. And it's 1 and 3. And so we see that this triples and we see that this also triples. So that means that X has to be first order. And the way I see that is it's just 3 and I'll do 3m equals 3, right? And then it's E. Okay? So I just did that without math. This is something you could see on the MCAT. All right? And then likewise, the rate of change of X, this is something we are just talking about at the beginning of the class or the like SI session. And so we have the rate of production of Z, and we have to just relate that with the moles, right? And so we see that for every, and this is for experiment 1, so 2.1 times 10 to the negative 4. For every 1 mole of Z, there's of like production of Z or appearance of Z, there's 3 moles of X of Z that are being, I guess, removed. Makes sense, right? So we can do 2.1 times 10 to the negative 4 times for every 1 mole, there's 3 moles, right? So we're going to get something around 6.3 times 10 to the negative 4, and it's going to be negative because it's disappearing. So that answer choice would be D. All right? So we just use the mole ratio and figure that out. Very simple math. It could be on the MCAT. And we see that there. Okay? So if you were taking the MCAT at some point, this question shouldn't take that long. Okay, and even on the professor uses exam, you know, he taught you how to do it using a bunch of math, but you don't really need a lot of that math. Because the nature of kinetics is pretty like simple, I guess. And it's gonna use simple numbers because it's something you guys just learned. But yeah, if you guys have any questions, let me know. I'll be ending this recording here. Have a good day, guys.